So for Scikit-Learn, basically everybody should be using pipelines. If you're not using pipelines, you're probably doing it wrong.
Hi, my name is Hebi-Chan Jung from towardsdatascience.com. Today, I have with me Andreas Muller, who is a core developer of the Scikit-Learn machine learning library, as well as his former release manager. You might know him through his book, The Introduction to Machine Learning for Python, a very popular one. He's also the associate research scientist at the Data Science Institute at Columbia University. I'm very excited to have Andreas join us from New York. Thanks for participating.
Thanks for having me.
All right, can we start with your professional background?
Sure. So I did my PhD in machine learning in Germany, in Bonn. I worked on structure prediction and computer vision there. After that, I had a short stint at Amazon at the development center in Berlin. I was there for about a year. Then I went to NYU as a research engineer. That's where I wrote my book. I spent a bunch of time working on Scikit-Learn there as well. And for the last 3 years, I've been at Columbia, first as a lecturer, then as a research scientist.
I want to spend a little bit of time talking about your book. So I noticed that your book has no math or formulas. What was the reasoning behind the strategy?
So I think there's two reasons. One reason is there's already a lot of really good books on machine learning out there. There were when I wrote the book, and there's even more now. For example, I really like The Elements of Statistical Learning, or the book by Bishop on pattern recognition and machine learning. And so there's a lot of really good books by really great people, and I felt like I can't really add much to that. The other reason is that I wanted to make it more accessible for people with a programming background. So traditionally, O'Reilly series are meant for like hands-on programming. And I think you can do a lot of stuff with machine learning, even if you don't understand the math. If you go into the details, you can get very easily into like details of linear algebra and convex optimization. And you can do a lot with machine learning without knowing about these things.
This is a question I'm sure that you get all the time, but we still have to ask, how did you get involved in Scikit-Learn as an open source developer?
So at first, I was a user during my PhD because I was doing my PhD in machine learning and was looking for libraries that are easy to use and that are like general enough for what I wanted to do. And so then during my PhD, I started doing like first some like typos and like simple fixes. Then I started contributing, I think, the kernel approximation. And then there was a sprint at NeurIPS conference, or then NIPS conference in Spain, and Scikit-Learn was having a developer sprint, and I asked if I can join, and they let me join. And basically at that sprint, so I was contributing a little bit already, but I was being quite active on the issue tracker at that point, I guess, because they asked me if I want to become the release manager, because the previous release manager was just sort of shifting positions and couldn't spend as much time on a project anymore. And so basically from that point onward, I was responsible for doing releases. Maybe that started like 0.12, 0.13, something like this, until like 0.19 maybe. It's maybe the last release that I did. Maybe 0.18.
Can you describe to us how the open source community works together for packages as popular as Scikit-Learn, and how are the workflow and the ownership of this packages like this structured?
That's a very good question. So I think for most people that are contributors, they start as users. If you don't use the package, I think you have much less of a motivation. And I think most of the good contributions are motivated by people's use cases. So there are some additions I made to Scikit-Learn because I wanted to use them. And these are usually the best additions. You don't want to cater to like two specific use cases in your software, but you want to make sure there are some use cases. You don't just want to tag on features because you can. And so having people that are users actually develop is quite important. And you can actually see this, I think, both in Scikit-Learn and in other libraries. The parts that are not used by developers are usually like slightly less well maintained. And so the things that are heavily used by the developers, they're really well maintained and well documented, and they're really nice. So yeah, first, be a user. So contribute to something you care about, and maybe you have some motivation to add something. But then on the other hand, for something as complex as Scikit-Learn, you probably don't want to start with adding some big new functionality. A lot of people have their favorite model and they want to start with adding their model to Scikit-Learn. But adding a model to Scikit-Learn at this point takes about a year. And so I really recommend starting with like smaller things. Like as I said, I started with fixing typos in the documentation. So really start with simple things. Improving documentation is always welcome. And like improving usability, there's lots of things on the issue tracker that you can start attacking. So really start with simple things to get your feet wet and go from there.
Thank you for that wisdom. What was your role previously as a release manager of Scikit-Learn, and what does it take to assume such a role?
Well, I'm not sure if it takes much to assume such a role. The point is more that this goes to the question about governance that I didn't really answer yet. Like things only get done if there's a person in charge sometimes, right? It's a very sort of distributed community, and really there's no one in charge, and we don't really want anyone to be in charge. We want it to be, let's say, democratic among the people who contribute their time. And but a release is like a fixed thing. You have to really do it. And so it's much easier if you have someone that's in charge of it, because otherwise it's hard to get done. And so you have someone whose responsibility it is to basically call a stop to development and say, okay, now we're going to actually release. And we're going to fix these couple of things and these bugs, and then we're going to release. And so it's more, I think it's more having someone volunteer their time to do that and do the cat herding. It's like the main qualification you have to have. In the last couple of years, I guess, I think it was mostly Joel Nothman, partially Olivier Crisel who did that. And right now we actually have a couple of people that are full-time on Scikit-Learn, and so it's easier for them to spend the time and work on making the releases.
Focusing more on the package itself, have you noticed any common mistakes or inefficiencies among the practitioners of data science implementing Scikit-Learn in their machine learning workflow?
So I think there's a couple of common mistakes, both for Scikit-Learn and for machine learning in general. So for Scikit-Learn, basically everybody should be using pipelines. If you're not using pipelines, you're probably doing it wrong. Also, I don't know, maybe 2 years ago now, we introduced a column transformer, which allows you to treat much better data that has both continuous and categorical variables or other types of mixed data. And you should, if you haven't looked at the column transformer, look at the column transformer. Also, we changed a couple of things in one hot encoder, and now everything is nice with using pipeline and one hot encoder and column transformer together. And if you don't do that, just look how to do it. It's great. So that's more in the like pre-processing and API side. A very common mistake that I see otherwise, that's sort of more for machine learning in general, is in not paying enough attention to the metrics. So Scikit-Learn, for better or worse, uses accuracy as a default metric. As soon as you have an imbalanced data set, accuracy is a terrible metric, and you should really look into using other metrics. We're not going to change the default metric because accuracy is so widely used and has such a sort of obvious interpretation, but really looking at different metrics and thinking about what these metrics mean in your use case is, I think, the most common issue in machine learning.
Two follow-up questions to that. One is, can you describe to us what pipelining is for those who might not be familiar? And the second question is, if not accuracy, what other metrics are much more preferable in the case of machine learning?
All right, so let me start with pipelines. So in Scikit-Learn, every machine learning model is encapsulated in like a single Python class, and we call these estimators. Very often, your machine learning process doesn't only have, like, say, a classifier, but it has a bunch of pre-processing steps. The pipeline allows you to encapsulate all the pre-processing steps and like feature selection, scaling, encoding of variables, and so on, together with the final supervised model that you usually have in a single estimator. So you only have one object that does all of your work. So that's very convenient. B, it makes it harder to write wrong code because it makes sure you do exactly the same thing with your training and a test set. And finally, you should probably be using cross-validation or use grid search CV to do model selection or something like this. And in these cases, it's important that all of the pre-processing happens within the cross-validation loop. If you do feature selection outside of the cross-validation loop, really bad things can happen. And using a pipeline, you know that because everything is encapsulated in a single model, everything is within the cross-validation loop. And so that's quite important. What was the second question? Oh, accuracy. So what metrics to use? So let's say binary classification. So I mean, classification is sort of the main issue where I think metrics are overlooked, somewhat partially also in regression, but actually I have less to say about regression. So in binary classification, it depends a little bit on what your goal is. So I like to look at things like area under the ROC curve and average precision. These are sort of very fine-grained metrics, also looking at the precision recall curve and the ROC curve. If you look at these, the issue with these is that they don't actually depend on a decision threshold you apply. So they are ranking metrics. And so you still need to decide on, if you make a classification, where do you set the threshold for saying, at what probability do I say it's class 1, and at what probability do I say it's class 0? Other metrics you could look into are like F1 metric or macro average recall, macro average precision. These are also interesting.
Perhaps in addition to the pipelining, are there other functions or tools in the Scikit-Learn package that you feel are being underutilized or undervalued?
Well, there is the column transformer, but I already mentioned that. The other thing is probably underused because it's very new still, which is hist gradient boosting. So we have a new implementation of gradient boosting that we released in the last version. It was done by someone on my team, Nicolas Huck. And so this is basically a reimplementation of LightGBM. And so it's much, much faster than our current or the previous gradient boosting implementation. It's slightly faster than XGBoost and slightly slower than LightGBM. Right now, it doesn't have support for missing values, but it will have in the next release in about 2 weeks. And right now, it doesn't have support for categorical variables. It's not. That's probably going to happen in like spring. But for example, XGBoost also does one-hot encoding. So you can still do one-hot encoding and use his gradient boosting.
Oh, it's interesting that you mentioned LightGBM because more and more different Python-based machine learning libraries are being released in addition to Scikit-Learn, right? CatBoost, for instance, along with deep learning frameworks like PyTorch. So I would love to hear your reaction to these constant developments. Do you feel more competitive with the growing players in the ML space, or do you have a different reaction to the trend?
I think, in most cases, plurality is good, in particular because of most of these provide some interface that's similar to Scikit-Learn, and so or compatible with Scikit-Learn, and so people can pick and choose what they want. Also, Scikit-Learn right now is, because it's very widely used, it's kind of slow in development, and so having people try out other things is really good. And we saw that XGBoost and LightGBM are hugely valuable to people, and so now basically we said, okay, this is so useful. We want to make sure everybody knows about this and can see this. And so we included it in Scikit-Learn to hopefully reach a broader audience and make sure it integrates well with Scikit-Learn. For the deep learning libraries, I think partially it is that it's good for that they can move faster because we would move way too slowly for this. But the other thing, well, there's 2 more things to it, which is one, we really have very little resources compared with Google or Facebook. And there's really no point for us in trying to compete with like a huge engineering team at Google or Facebook. And I really if we pit each other against these, we can only lose. And there's no point in doing it. I think Keras is really cool. And I haven't really worked with PyTorch a lot, but like Keras is a great tool. I use it for teaching. I'm like, there's no reason why I need to re-implement something like this in Scikit-Learn. And there's a little bit more technical reason, which is that still right now it's kind of hard to do GPU support seamlessly across different platforms. And you can see there's like different versions for TensorFlow compiled for different architectures, and sometimes you have to compile it yourself and so on. And so we're going to not have that hassle, but also really, I don't think there's a point in us redoing the work that others are doing. And I'm happy for like Facebook and Google to compete and us be like outside observers.
So it seems like you have more of a collaborative spirit where it's kind of a mutual benefiting situation where in certain cases you feel like you can take a Scikit-Learn, in other cases you feel like PyTorch or other methods will be much more beneficial.
Yeah. And like, I mean, for deep learning, it's very clear that you don't want to, we have something in Scikit-Learn, but you don't want to use that. If you want to do deep learning, you'd use one of the big deep learning frameworks.
Actually, I'm kind of curious. So what kind of deep learning frameworks are within the Scikit-Learn package?
Oh, I mean, there's no frameworks in it. There's, we only have like a standard feed-forward neural network, and I think we have our restricted Boltzmann machine, RBM, which I guess these days no one is using anymore. I don't know. But so one of the things is we don't build on any autograd framework, so we have to write down the gradients all by our hand, which
Wow, that's incredible. How do you do that?
I mean, that's like what everybody did, right? Or what everybody used to do. And so that makes it hard to implement some things. And we don't have GPU support, so it's like you can't really scale. So it's more there if you're like, oh, I trained a random forest and it worked. Let's try a new MLP and see if it works better. But then if you really want to do something, you should go to one of the deep learning frameworks.
I see. On a more personal level, your work has been about democratizing the use of machine learning. I want to ask, how did this philosophy of open participation come about?
So I think very early on, I was quite fascinated with like hacker culture and open source. I think I started exclusively using Linux and compiling my own kernel at like 14. So, and that was I was just sort of fascinated with that. And then also in Germany, the academic culture is somewhat different. And like from a US perspective, Germany is socialist, right? All higher education is free. There's like, I didn't have to apply for a school. I could just enroll and I didn't pay anything. So it's like, it's in a sense much more open, at least on the level of the students. And so that really sort of is in the spirit of free exchange of ideas.
You're also as I mentioned, a research data scientist at Columbia, and you teach the classes there as well. And one of the lectures that you've given at Columbia is imbalanced data, which is a very common but exhaustive and extensive topic in machine learning. As you've noted yourself, there are two basic approaches to this problem, right? So one is you build the standard model after changing the data, such as undersampling or oversampling. And the second method is to change the model you're building, that is, changing the training procedure itself. So can you tell us what are the advantages and the disadvantages of these two methods, especially in relation to Scikit-Learn, if you can?
Sure. So yeah, so this imbalanced data is like a huge topic, as you said. And so I want to take a little bit of a step back from your questions. I think the most important thing, again, is metrics. And think about how do you evaluate it? What is your goal? And so your goal is never accuracy, but your goal is also never rock AOC. That's not what your application is about. So you should think about what does it mean in the context of your application to make a particular outcome. And so then once you have this goal, you can define correct metrics, then you can try different approaches to maximize these metrics. I guess one thing that is very attractive about resampling is that you can often throw away a lot of data without really impacting the results. So if you have like 1 to 1,000 class ratio, maybe you don't want to undersample it to 1-to-1, but maybe you can go to 1-to-100 or 1-to-10, and you get exactly the same result. And you now reduce your data set by a factor of 100. So at least if you have a lot of data and sort of computation is possibly an issue, I think undersampling is a way to get a similar result much more efficiently. I have not really seen people use SMOTE a lot in practice, which is like synthetic sample generation. It's something that people talk about a lot, but I'm like a little bit skeptical about. In terms of changing the model, I mean, one thing that's in Scikit-Learn that I think people often use and that's helpful is class weights. Class weights actually change the loss function so that it is as if you oversampled the minority classes. So you're using all of the samples, but you give more weight to the minority classes. And that's something people have found useful. But again, it's more like try out the different things and make sure you have the correct metric to assess which solution works best for your problem.
You know, it's interesting that you talk about SMOTE in that way because at my company, I try out and experiment with SMOTE all the time. But one of the results that I get with actual data is that there's actually not a huge benefits in terms of whether it's RC or whatever metrics that I'm using. And in fact, it just takes so long for this whole pipelining to work, right? Because you're creating all these synthetic data. I want to kind of understand from your point of view, where the doubts of SMOTE come from.
Well, because everybody I talk to tells me exactly the same thing that you just said.
And why do you think that's happening?
To me, okay, I'll try to answer your question, but to me, like a lot of things in machine learning are very empirical. And so it's like really, if you try it on many, many data sets and it doesn't help you, well, clearly it's not helping you. Like it's very hard to say, why does gradient boosting work well? And I don't think anyone has like, I think most people are convinced gradient boosting works well. I don't think anyone can make a proper argument why boosting works better than support vector machines. I don't think anyone can really explain that in a concise way or in like in a meaningful way. But so I guess SMOTE makes some assumption about the distribution of the data, and so it could be two things. Either the assumption is wrong, so it adds like these lines between sort of neighboring samples, and if the sample is too far away and there's samples from the other class in between, for example, then it might like break things. Or so it could be that sort of the assumption of the model is incorrect, or it could be that just like adding these synthetic samples doesn't actually help for the classes of models that we're interested in. And yeah, I don't know. So I think it would actually be quite interesting. So I'm actually have a plan to, with a collaborator, to work on a paper doing some extensive benchmarks because, yeah, as you said, it's like there's probably some reason why you're trying to work on try to use it because sort of this is the proposed method that you can find in the literature, but in practice, people often find that it doesn't do that much for them.
No, it's very important that you say that because even though there's a science bit in data science, there's still very much a gap between what is taught and what is studied and what is actually practiced, right? And it's very important for us to have that practical knowledge to see the gaps in our theoretical understanding. With that said, I wanted to ask you the final question, which is, do you have any words of wisdom for the TDS community, particularly those who are getting into open sourcing as a creator or perhaps a contributor for existing project like yourself?
So I think working in open source is definitely a great learning experience. Though if you want to contribute, I don't think you should, if your motivation is to learn, or if your motivation is to sort of get an item for your CV, then both you and the project are going to have a bad time. I think you need to really want to contribute because it's a lot of effort that you have to put in particular if you want to contribute to a bigger project. Like the bigger the project, usually the more effort is to contribute. But I also find that hugely rewarding to see that so many people use the software that I'm working on. And like whenever I make some improvement, there's lots of people who can benefit from it.
And that's all the time that we have for today. Thank you for joining us again, Andreas.
Thanks for having me.
Thank you.